Okay, hello everyone. So same deal as always before every exam. This is my mini exam review. Remember, I'm not really going to give you guys any of the answers for these. I'm just going to focus on some key concepts that I think are really important for this exam. If you guys have questions, if you want to like screenshot the slides and fill out the blanks yourselves and kind of send them to me and we can talk them over, we can absolutely do that. Remember, I don't take questions starting on Tuesday because that's when your exam opens. So you can email me about the exam up until Monday. My office hours just finished today, but if you wanted to email me and set up another time, we can definitely do that and talk out some concepts because I do understand that this module can be a little bit confusing. So before we get into that, a couple announcements. So again, next week, no lab. The following week, no lab. So it's Thanksgiving break. Technically, there are class on Monday and Tuesdays, but no lab for us. So that just means you guys get 2 weeks of off of lab, and I won't see you guys until December. So enjoy. Okay, let's get into this. So I'm trying to make sure like my face doesn't cover anything. The pathway from calcium release to the cross-bridge cycle. So you guys all know that calcium is released from the sarcoplasmic reticulum. It's going to float over to the sarcomere, and then it's going to bind to all these things, and that's going to help form a cross-bridge between myosin and actin. So you guys can try to fill in these blanks. Like I said, this whole exam is pathways and graphs. I love a good pathway, and this is how I study. And so I would definitely try to write out everything you know and see if you can put it in a pathway, and I promise you it'll help so much. Continuing that pathway, so when there actually is a cross-bridge interaction, how do we get a muscle contraction or the start of a muscle contraction? So start from the cross-bridge state and then over to the Cox state. You guys did this in your drawing activity for lectures, so refer back to that and just make sure you really understand what's going on. Okay, so length tension curve with active and passive, passive, and total tension curves. So if you guys really need to, you can use lab 6 isokinetic dynamometry and kind of refer to those figures and maybe my notes in the bottom of the slideshow for you guys to help. But remember, when you are going through every graph, you want to look at each axis. You want to draw the actual figure, but then understand what's going on at each point. So when you draw it, you know what kind of contraction is occurring at 1, 2, and 3. And can you include the active, passive, and total tension curves and completely understand what they mean? And they can get a little confusing, especially passive tension and then total tension. Okay, so see if you guys can do that on your own. Again, if you don't understand, please feel free to ask me. Force velocity curve. So again, what are our axes? And then what kind of contraction do we have? So make sure you know your eccentric, your isometric, and concentric, but also know what Dr. Clark's terms are. So eccentric is a plyometric contraction. A concentric action is a myometric contraction, right? So I'm just making sure you understand all terms and what's happening at each. And when you're taking a look at this graph, you know which one is producing the most force, what kind of contraction helps produce the most force, and why. Can you relate what you're seeing on this force velocity curve back to the length tension curve on the previous slide? Because that's going to help explain a lot of things. I know eccentric actions are kind of confusing because you're like, wait a minute, why do we produce the most force when we're stretching, when we're not actively contracting? And remember, that's where passive tension really comes into play. So think about it. Dr. Potter uses the example of an eccentric action for a squat. So imagine you're going up to do a barbell back squat and you start in a already full 90-degree squat position and you try to push up against the bar. That's a concentric action, right? That's standing up against gravity. That's a concentric action on the quads. You're not going to be lifting as much weight because you can only produce so much force. If I asked you to hold that 90-degree squat position, so an isometric contraction, and I kept throwing on plates, you'd probably be able to tolerate a little bit more than if you were to ask to push that weight up. And then finally, if I told you, okay, rock the bar, now let's start in a fully standing position, and I want you to lower this weight as low as you can go, you're probably going to be able to lower or help lower more weight than you would be able to push up against that weight, right? So maybe, I'm starting in that 90 degrees, I can only push up 45 pounds on each side. If I do an isometric squat, maybe I can support 2 plates within that squat position. And then if you just ask me, okay, I need you to slowly lower this bar, I can probably slowly lower 3 plates on each side. That's because an eccentric contraction has all of that passive tension, which is helping produce more force and allowing you to kind of tolerate that much weight. Can I actually lower 3 plates on each side? Absolutely not, but that's an example for you guys to think about. So that is all the like muscle stuff. Now we're going to move on to respiration, and he's going to hopefully release something today, some supplementary material. I would highly recommend watching it because it's going to help clarify some things, and he's going to pull some questions on there into his multiple choice as always. So always watch those kinds of lectures. This you can look at straight from the slides. So thinking about, what muscles do what. So remember, our diaphragm is pretty important. So when the diaphragm is relaxed or it's contracted, are we inspiring? Are we expiring? And what are some accessory muscles that can be used when we're starting to more actively inhale and exhale during exercise? This again is straight from the lab, so you guys are welcome to look at those slides, but knowing all of the definitions for those, because those might be some kind of multiple choice questions. Solving for minute ventilation. So I gave this example. I think Dr. Potter gave this example in his lecture. So just be able to calculate that. If the numbers were a little bit different, what's the formula? And then how would you calculate that? And then everyone's favorite, hyperventilation. And the next slide is the Valsalva maneuver. It can get really confusing because you're just like, I don't know what is happening right now. Again, write it out as a pathway that really kind of helps you chunk it up and really gets to see the connections. And so I tried to create a pathway for you guys to follow along as best as possible. I understand the way I write my pathway may not be the exact same that you write yours. And so our blanks might not correlate, but you can see if you can get the right idea and make it to that last step with the same relative terminology that I use. Again, I know I'm not giving you guys the answers or the slides, but feel free to pause it, work on it, move on to the next slide. And then same thing for the Valsalva one, right? So what happens when we do the Valsalva measure and how can that lead to someone passing out? And then why does that increase our risk, right? So really think about pressure. What are we kind of clamping down on that allows for blood flow to the brain? Okay. This curve is the most important one out of everything. So really make sure you guys are understanding what is going on each axis, what the curve looks like, and then where is the location, right? So I ask, is it in the lungs, muscle, or mitochondria? So, number one, when we are looking at this point in the graph, are we looking at, are we in the lungs right now? Is it a loading phase, or are we in the muscle and we're unloading oxygen, right? Number 3 is important, and then number 4. Then knowing the partial pressures that kind of relate to the partial pressures that relate to the oxygen percentages for each of these time points and locations. And then add your myoglobin dissociation curve. So that's these boxes in green. So kind of taking a look at those common values that he talks about. And what is myoglobin compared to hemoglobin, right? What are they transporting it and where? So thinking about that and understanding that. And then probably the last thing that's another important thing for that same curve, how does it shift when you increase or decrease temperature or pH? And what does this shift mean? So if we took this line and we went back to this figure, if I drew this line here, how does that change the partial pressures? And how does that change the oxygen percentages? And can you tell me why? That's it, guys. Good luck. Again, if you guys have questions, please let me know. I will be happy to answer them through email. We can set up a Zoom really quickly. You can even run through these slides with me through email. Good luck, guys. Again, this can be a bit tougher exam. Multiple choice may be a little bit easier, but the free response can get a little bit tougher because it's really asking you to analyze and critical think, and that's not always what you guys are used to in these kinds of exams. So make sure you guys really get in there and you really understand the material, because again, time management is key. Do not waste time looking through your notes when you need that time for free response and everything like that. So not too many, I don't think there's any diagram questions today. Like you're not going to be drawing anything, but beware of a lot of typing and a lot of looking at graphs. So that's my tip for you guys. Good luck, guys. You guys are gonna be great. I'm excited for you. You're almost done. The semester is almost over, so you guys got this. And email me if you have questions.